Assalamualaikum. Hi, my name is Nur Atikah binti Leman. I'm from Faculty of Electronic Engineering and Technology. My research is about enhanced time difference of arrival with Kalman filtering as object on ground localization acoustic sensor. Today, I will present about my assignment 2. This assignment has 5 parts, which is first, fundamental of research. Second, summary of the different technical aspects related to my project. Third, summary of the past studies. Fourth, the gap in the existing knowledge. And lastly, proposal conceptual solution. Fundamental of the research project. As we can see, the figure shows the basic technique of the localization algorithm. Localization has two types, which is first, underwater localization algorithm, and second, on-ground localization algorithm. The scope of this project is on-ground localization algorithm. Localization algorithm for sensor network can be classified into two groups. First, range-free algorithm, and second, range-based algorithm. The project involved the range-based algorithm because it was more accurate than other one. There are four main approaches of range-based. First, angle of arrival AOA. Second, time of arrival TOA. Third, receive signal strength RSS. And fourth, time difference of arrival TDOA. AOA is a technique that allows each sensor to evaluate the corresponding angle between the received signal. TOA is used to determine the distance between a mobile station and the nearby synchronization base station. RSS is indicator is applied to translate the signal strength into distance. TDOA use time difference to reception of signal. TDOA is chosen as it offers the high accuracy localization than other method in low noise environment. The goal of this project is to improve on the object localization while avoiding any new expensive hardware. We decide to use a software algorithm solution for any improvement. In order to enable real-time monitoring, we plan to construct a filter that could precisely filter data using the localization information on board. Numerous filters are available to obtain greater accuracy information from noise data, sensor network integrated of previous knowledge. The Kalman filtering is an interactive condition estimator that is commonly used to find an item in the presence of noise measurement. It is used to filter noise and is implemented using a linear algebraic formula. It estimates the system state variable at each time step using a succession of noise measurement and the virtual evolution of a mathematical model. It is accomplished by employing a joint probability distribution over the variable. The capacity to estimate state at a pace faster than the sample frequency of the sensor, including is a significant advance of this technology. As previous stated, we choose this form of filter to improve object localization because our application operation is a continuously domain with a whole wide and unknown range of the operation and the ability to accept the Gaussian assumption. The implement of the strategy involved the development of the mathematical model of the physical system as well as the appropriate estimation of the noise signal characteristic. The triangulation method is the one method for accomplish this. Triangulation is a technique for determining the position of the sound by measuring the distance and direction of the received signal at three independent points. In this work, this approach required only 3 sound sensors for 2-dimensional instance. To simplify the calculation and reduce the error, the sound sensors are arranged in an equilateral triangle. Now, we talk about the summary of the different technical aspects related to my project. From the paper and journal that is related to my project, I focus on 3 different technical aspects, which is localization technique, second, method to calculate distance, and third, the algorithm or filtering that is used to reduce the noise environment. From article 2017, when it said when using TOA value for source localization, it is frequently assumed that the source and the sensor node work together to identify signal propagation time at each of the sensor nodes. The collaboration between source and sensor node still does not always achievable. As the result, without identifying the initial signal transmission time of the source, the sensor cannot figure out the signal propagation time using TOA only. Based on the second article, they use weighted trilateralization as the modification from the original trilateralization algorithm because the 3 measurements do not always intersect to the same point. Triangulation method is needly clear line of the site between the reference coordinate and the object, while trilateration does not need clear line of the signal as long as it has accurate distance value. For the last article from Kim and Park 2020, said while obtaining measurement and extended Kalman filtering was built to reflect the characteristic of each sensor, which is LIDAR and radar. The research confirmed that the LIDAR and radar sensor fusion improve distance measurement more accurate than the technique that is reflected distance error was improved in the extended Kalman filtering composition. Summary of the past or previous studies. I had been studying 5 past papers that related to my project. First is sound localization based on acoustic source. The algorithm that I find in this article is generalized cross-correlation and also use the trigonometric function. What I find in this article is by working with the real acoustic signal at the optimal frequency, this study used TDOA combined with the GCC algorithm for better TDOA calculation result. A pair microphone array, each which 2 microphones were used in this experiment. The result of the experiment show that the proposed method can identify the sound source and achieve good performance, which is position error of the 2 until 2.3 cm and the angle error is 0.74 degrees. Second paper is research on the acoustic source localization using TDOA measurement. This paper also used generalized cross-correlation algorithm and also used Taylor algorithm and Chan algorithm. So in this paper said the cross-correlation is a primary approach for the estimating time delay for basic signals such as sound, and generalized cross-correlation is typically used for a high accuracy. Using the TDOA algorithm, the Chan algorithm is a direct method for solving quadratic formula, whereas the Taylor algorithm is an interactive technique. In this algorithm section, modify Taylor algorithm with the initial value swipe with the result of the Chan algorithm has been suggested for the use in a real-time localization system. Testing result show that the modified algorithm achieve more accurate than before, which is traditional Chan and Taylor algorithm, which is 3cm, which favor calculation. Third paper is underwater acoustic source localization method based on the TDOA using particle filtering. This paper used novel algorithm and particle filtering. So in this paper, the particle filtering is applied for estimating the stage of the sound target, which is location. The particle filtering based on TDOA method was pitted against the traditional Chan technique. According to the result, the particle filtering based on TDOA method has a low RMSE, root mean square error, showing a high level of stability, while the RMSE of the Chan method is much greater than that of the particle filter method. This indicates that the method is less stable due to the reverberation and multipart propagation interference. The next paper is a survey of a recent indoor localization scenario and methodology. This paper also discusses about the variety of the localization technique in detail, which is TOA, RSSI, TDOA, RTT, AOA, and others. The research also highlights the use of the common technique, for the example of RSSI fingerprint and NN-based classification regression technique. The gap in the existing knowledge. By applying acoustic method to detect the location, the drop object on the ground based on the wave, the challenging problem is to estimate the noise and uncertain of the noise from the ground. In no kind of filter is developed, the embedded system in the ground will not be able to differentiate between the sound from the impact of the dropper object and any other source of sound. This challenge aspect of this project would reduce the effectiveness of the acoustic method. Last part for this assignment is proposed conceptual solution. Wireless acoustic sensor network is proposed for agriculture application, in particular to detect and locate the dropped object or fruit based on the sound of the impact on the ground. The location of the dropped object fruit is calculated using the developed algorithm based on time difference of arrival, TDOA estimation, using the collected information by the wireless acoustic sensor network, followed by the Kalman filtering stage to smooth the time serial of estimation, removing uncertain out of the measurement due to the noise environment. This dropped object detector will effectively localize the dropped object by utilizing an acoustic sensor that is competent to detect dropped object combined with the real-time system. The whole system will be working based on the time difference of arrival, TDOA, based on direct method. The location of the dropped object will be determined based on the simultaneous time of the arrival, TOA, or three-stage range measurement. In other words, it finds the distance between the dropped object, which is station, and determine the intersection point of three circles in 2D. Without editing costly hardware, the exact location of the source of acoustic wave in the ground from arbitrary distance and direction can be estimated until the accuracy of meter by eliminating this uncertain using developed algorithm. Apart from the proposed algorithm, this work will implement triangulation technique that use angle, distance, and trigonometric relationship to help the locate an exact location of the dropped object or the fruit. The algorithm and the technique developed in this work could be further developed into a commercial localization system for the real-time dropped object mapping system in the form of the mobile application. That's all from me. Thank you.